the next person coming in, and that will be because of you heard that we have a cancellation. Then Micha Sörgel, who is actually a former Folkecenter trainee, and he will go in and substitute the presentation from Blue Wind. And his presentation is called Wind Energy for Your Home. And please, Micha, go on.
Thank you very much. Yeah, first of all, I would like to say it's kind of a spontaneously presentation, so I hope I still will get everything right. 1 second. Can you see the presentation now? All right. So it's like how to use a small energy or small wind turbine for your own home, for example, to charge batteries or to get light in your house. And therefore, we tried at Folkecenter in the last period. So I was there from October till January in the last year. And we built this offshore construction. I will tell a little bit more about it in a second. And we used the wind turbine to provide lights for the parking station. And well, first of all, about the platform. This is the platform we built. It's kind of a sandwich with 3 barrels, which make sure the wind power station can float in the water. And we used an old report from another student, another trainee from Folkecenter, and changed it a little bit so we could use the materials we had at Folkecenter. And of course, we tested the platform as well and had a lot of fun at it. We did it at a fjord close to Folkecenter, and the whole construction had a weight of around about 150 kilograms, and we were not even 20 centimeters inside or deep in the water. So you could also fill in the barrels with a bit more sand to make sure the platform is more stable. For the testing, we did not connect the wind turbine to anything. We just fixed it to make sure it won't spin too fast within the wind. And yeah, well, we had the 17 centimeters water depth until the group that made the platform, we went onto the platform to test how deep it will go in, and we realized it is a huge difference how much weight we have on the platform, but it was a lot of fun. And well, about the circuit, how to use the DC wind energy from a 400 watt turbine. First of all, we of course have to rectify or use a rectifier to change the AC voltage to a DC voltage, and therefore I used several old diodes from old components and to get the DC voltage. And of course, we have the problem how to limit the voltage to a certain level, and we wanted to have a 5 volt DC level, and therefore we used some transistors, and we knew the gate source threshold voltage of 2.5 volt, and within 10 kilo ohm resistors we could double the voltage to a maximum of 5 volt. So when the wind turbine starts spinning very slowly, the transistors do not let any current pass, so we can add at the end of the circuit anything we want, for example LEDs, to make to get light. And when there is high wind speed and the voltage increases and it reaches the 5 volt, at that moment the transistors switch and they get like a shortcut to make sure there are high currents which slow down the turbine, which is very important as well to be able to limit the turbine speed. And still we can use all the energy we need for whatever we have as a consumption, and everything else, all the other energy is turned into heat within those transistors. This of course shows that we have to added to a metal board or a heat sinking to make sure we can get rid of the heat without destroying components. There we have like an example of a system we had indoor as well, this time with a Cine diode, and we added a capacity to balance short voltage changes, and we used it to get light within some rooms. This is the outdoor circuit within a break as well. So we have a switch here, and whenever we want to break the turbine, we simply shortcut the 3 wires, the AC wires, and make sure we have high currents inside the generator, which slow down the turbine on its own. Then we set up a 400-watt wind turbine. This is made by some other trainees. The blades made out of wood with a diameter of, I think, 1.8 meters. And we set it up on the turbine, on the platform onshore then to make sure that people can see the platform. They can have a look at it, and to make sure it's stable enough, we filled the barrels with sand. So we had a total weight of around about 1.2 tons in total. Then I, of course, fixed the circuit and the brake close to the wind turbine, that in any emergency case or whenever you want to break it, you can do it right next to the wind turbine. We used it at Folkecenter at the parking lot to get light whenever there's wind, but there is no battery system included in here, so we have only light when there is wind spinning at the same moment. As a for the light, I just used a very simple system, putting some LEDs around of a wooden stick and connected them to the system, and adding like a yogurt cup to make sure it's waterproof and we have more light increased. Same with the aluminium down there, it's just to spread the reflection of the light. And we did the same system, or kind of the same system, indoor as well, but there we had some other components, including also a battery system. Therefore, we used 2 3.7 volt batteries from an old e-bike battery, which was broken, but those 2 were still working. We connected it. Of course, I had to lower the voltage limit to 3.7 volt here as well to make sure the batteries won't get damaged. And I also added a measurement to see how much current is generated by the wind turbine, or how much is consumed from the batteries. And this system was working 24 hours a day, and within those 2 3.7 volts batteries, I think they should have a capacity of around about 1 amp per hour, but I'm not sure about that. But with this system, we could power the light in 1.5 rooms all day, all night, just with the wind turbine spinning and the batteries, using the brake to power the LEDs. So this is also a system you can easily use at your home if you have a place where there's a lot of wind. And for example, for tiny houses, it could be perfect because you can switch it off whenever you want, but you can use it off grid and use the energy from the wind. That's it as well. And if you have any questions, feel free to ask.
Thank you very much, Micha. It was very interesting what you have been doing here, and see that even at a low practical level, it is possible to do something, and everybody has to do something, start somewhere. We have a question from Brooke Spreen. Please, Brooke.
Yeah, there we go. Hey, looks like a super cool project. I was wondering, was there like a dump load in the system or anything, or how did you do energy balancing?
Well, we had like very small capacities in parallel to the system to balance small voltage changes, but we had nothing bigger. So just the batteries and the capacity in the inside system, but outside within the offshore platform, we had no capacities.
And so was there ever any worry of overcharging the batteries, for example, or?
Well, I worried a bit because I didn't know too much about it, but I just tried it and checked it like on the first day. Every 5 minutes I checked whether it's fine or whether it's heating up, but there was no problem in the time I was at Folkecenter, and I hope it's still working fine.
It's cool. It seems like a really cool project.
Thank you.
Yeah.
And yeah, I had one question. What was the cost that you incurred by total cost for your setup?
Well, it's difficult to say because we just used things we already had at Folkecenter, so we didn't buy anything special for that. But of course, you have to have a 400 watt generator. You have to have some wood. You have to have the components. So like the transistors are around about €1 each, but the generator is probably the most expensive part. So I guess there you have to, well, I guess you're probably around a couple of €100 for the generator, and then of course you have to have a look what is around yourself. So we didn't want to buy everything. We just had a look and tried to use and reuse stuff we had. So we also, for the offshore construction, we already had a report, an old one, but we changed most of it because we didn't have the exact components that were used in the report. So, well, it's very difficult to say, or I can't say an exact number. I'm sorry.
Yeah, thank you.
Are there any other questions? It seems not to be the answer, yep. But maybe then I don't know if Dr. Nasir Al-Rifai is ready to go in. Our next presentation will be about the ONIPCO rotor with high efficiency and presented by the Design and Communication at ONIPCO Group in Ukraine. We heard a little bit about the ONIPCO earlier today and a bit yesterday as well, I think. But we really look forward to hear about this design. Are you ready, Dr. Nasir Rifai? Oh, sorry. Yeah, your name is Nisar. Sorry. Nisar Al-Rifai, are you ready? Well, it seems as you're not ready yet. I know that we are about 3 or 4 minutes ahead, so that will maybe go a little minute or so. It's good sometimes to be in a good time, as we are here, and most of the time we've been a little bit delayed, but it seems as it can go the other way as well.
Martin, can I ask another question if we got a minute?
Yes, of course.
So this, I don't remember the exact term, but what Micha was just talking about is was it an internship or a project at the Folkecenter? Maybe could you talk a little bit about this? And it sounds like it's an educational opportunity sort of thing.
Yes, we do have some educational opportunities, and I think that we will later on give a short briefing about the possibilities for the place here. And you will see that it is all sort of people coming here. It's even grown up to say public servants from around the world coming here and take a stay for 2 or 3 months just to make sure that they know about renewables and all different sorts of renewables. So actually, yes, you can have a very good basement for knowledge about renewable energy and how to produce it from Folkecenter. And that's why we have trainees, and the trainees has been coming here for decades, and they are still coming. Right now we are having 4 trainees at the place, and they are queuing up to get here. Actually, we can only have so and so many at a time. So it is quite popular going here, both for youngsters, but also for some a bit older people. Yeah, but anything you will find it at the homepage for the Folkecenter as well, which opportunities there are. Danielle will put a link to all of you now, so you can go in and have a look at it, what options there actually are. I hope that can answer your question.
Yeah, super, thanks.
That's good. Are there other questions right now? No, it seems not. But anyhow, about the trainees, the reason why the trainees are coming here are that there are very, very few places in the world where you actually can see all sort of renewables and how to desalination, and you have a huge problem with and all other things you'll find here, and you also will see how they are connected. Normally, you'll see only one type of a renewable, that could be solar panels, but how to make the hybrids and how they actually can interact, that is possible to learn here, and to get a overview of what is actually going on. So a lot of these people coming here, the youngsters, most of them are already educated as engineers when they're coming here, and then and they have bachelors, and some has even a master's. And they find all that they really can bring something away from here when of knowledge when they leave the place. So it is never too late, I will say. So there's a question, yes?
Can you hear me?
Well,
I will do it from here so we don't have double noise. So, well, basically
well, there was still some double noise.
Sorry. So basically the trainee program, it's not only something for engineers. We actually welcome people from any kind of education, because at the end in renewable energies, you can get through different aspects. So you can get from a more economical point of view, a more social, or a more technical. And throughout the years, we have had this combination of people from different backgrounds and different groups. And that was also when Micha was here. There were, I think, 8 trainees from completely different fields. And you could see in the picture, they were all working together on a project. So what it works normally is that people get assigned a project, and then they can get it either individually or as a group. And then we would welcome them to try to do it in practice as much as possible. So this floating wind turbine actually has been completely designed and developed by trainees. From the early design to the setup, the blade construction, the testing, everything has been done by trainees, by different groups of trainees within the year. But anyway, you can find more information about the program in the link I put, and you can always contact us for more information.
Oh, thank you very much, Daniel.